In this short video, we're just going to do a recap about what you know from fractional distillation at GCSE and maybe just tweak it a tiny bit to make it more A-level appropriate. So crude oil that we extract from the North Sea or petroleum is a mixture that is mainly alkane hydrocarbons and is our source of fuels and petrochemicals. Petrochemicals being any chemical that is produced from crude oil. Fractional distillation is the separation of the liquid fractions which differ from their boiling point. So let's just highlight that because that's quite an important factor. So they differ in boiling point. Each fraction have a similar boiling point and are removed at the same level in the fractionating column. Okay, so we've got this whole crude oil. We pump it into this furnace down at the bottom and we heat it. So we heat the oil to vaporize, turn it into a gas. In it goes to the column. Now the bits that didn't vaporize, that didn't turn into a gas, are going to drop to the bottom, and they're really hot because they're as hot as we could get them and they still didn't turn into a gas, and they're going to come out at the bottom. So these are the things with the highest boiling point fractions are going to come out down here. They never actually boiled. And the highest boiling point fractions are the longest. In fact, let me just change colour so that we can separate it. These are the longest chains. Because we just seen in a previous bit of work that the shorter chains have lower boiling points. So at the very top, we've got the shortest chains, the things that are gases at room temperature. And that'd be things like methane, ethane, propane, and butane. And they have the lowest boiling points. Okay, so our temperature gradient is increasing as we go down or decreasing as we go up. So what happens is the gases rise and they hit these little caps. Now, if these little caps are the right temperature for the particular thing to condense, turn back into a liquid, it will hit the little cap and it will drop into the trays. And then we'll tap it off. If it remains a gas, it just continues rising up until it hits its boiling point and condenses out of the trays. So crude oil is vaporized and the vapor is introduced near the bottom of the column. The vapor rises up and creates a temperature gradient. Because the alkanes have different boiling points, they condense at different levels, and we can see that we've written this on. The lowest boiling points do not condense and come off at the very top, and the largest hydrocarbons can't vaporize and they come off at the bottom. So it's a process that separates components which differ in their boiling point, and each fraction has similar boiling points. So all the gasoline fraction have similar boiling points, all the kerosene fraction have similar boiling points, and so on. It's a group of molecules that have similar size and therefore similar boiling points.